Hello, welcome students. Let's be together again. We need to finalize the whole topic of the quadratic expression and equation by just looking something on the practical problems. Here we're talking of the application of the knowledge of what we have just learned in class. Practically, is this knowledge worthy to be considered? So the answer is yes. So here with me, I'll give an example of a problem that needs application of what we have learned about the quadratic expressions and the equation. So let's be together and try to work out this on this one until we finish it out. Right, so let me write the example on the board. Right, we have a man, right, they say is 5 times as old as his daughter. We are now told that, say, 6 years ago, the product of their ages was 324. Now the question is, how old are they now? Right. So it's more likely we need to work out the present ages. That's the age of a man and age of a daughter. Right. So let's get through. It's really a large type of problems. We've got so many of such kinds of different angles. But now we have talk of the man who's compared his age with a daughter, but we don't know their ages as such. But with the information given in the question, we may be able to pick out the age of the two. Right. Now, to handle such type of question, as mathematicians, we would need, at least first of all, to summarize a little of the weights which were given here. It's more like English of that kind, but we take it now into mathematics. There's so many statements there that has to be analyzed out and then come up with the mathematical statements, which are just like expressions and terms. So this is the way we go. A man is 5 times as old as his daughter. Here, what is trying to be stipulated here is just an issue of the comparison between a man and a daughter. So when you come up here to solve out the ages of the two, you first have to pick that one down. Those are just like the theme of the whole problem. So here we have like a daughter, and you also have here a man. These are the two areas of concern. So we are comparing the age of a man and a daughter. So what is the question saying? They're saying that the man is 5 times as old as his daughter. So we'd like to find out the present ages. At least you need to analyze sentence by sentence of that question and try to interpret it into mathematics. So like here for the first statement, a man is 5 times as old as his daughter. What does this mean in mathematics? Right, so here it sounds like age of a daughter is not known, yet that age which is not known is compared by the age of a man. So what we do in mathematics is that if you do not know the age of somebody, or you don't know the value of a certain variable, okay, we represent that quantity by a certain letter. Like here, we don't know the age of a daughter. So here we say, let the daughter be equal to maybe X. So it means throughout our discussion, we'll be using a variable X to work out the age of the two people, man and the daughter. So by now comparison here, if we let the age of the daughter be equal to X, then obviously what it sounds in this first statement, when we say 5 times as the daughter being the age of a man, then it means the man should be 5x years old. So here we're going to assume that at present, the age of a man and a daughter are represented by the following expressions. X is the age of the daughter, and 5x is the age of the man. That's the way we go. So you can see, this is mathematics, but this statement is English. So take English into mathematics. Then another statement here will say 6 years ago, So 6 years ago, it is something that tells us about the past. So mathematically, that counts. What does it mean? It means automatically everyone's age can be subtracted by 6, or anything that is at present. If talk of 6 years ago, it's automatically being subtracted. Even the dog's age will go backwards by 6. So since here we are discussing something about a dot and a man, then now here we have an expression that can present this statement, like 6 years ago. It means if now I am 50 years, it means 6 years ago to be 50 minus 6, which I'll be 46. So I'll be 44 years. And if now I'm 30 years, it means 6 years ago I was 24 years. So it goes by that. But now here I've got a daughter who's X years. It means 6 years ago, the daughter now will be X minus 6 years. And a man, it will be 5X minus 6. That's the way it will be. So when you write these expressions, it should be just like more like little translation, but not necessarily. But what it means there is means that say you are always working out on the edge of the two by representing the variable x to mean the age of the daughter. So you go by like that. So whenever you look at these expressions here, when you read them out, make that you understand that x is the age of the daughter, you'll be able to reconcile with what we have there in the statement. If the age of the daughter is x, age of the man will be 5x. That is by the first statement. Secondly, 6 years ago, what is it? Just 6 years ago, you'll be able to tell that you have got already a change in their ages. So it means the daughter will be x minus 6, and the man again automatically will be 5x minus 6. Now the statement also goes on to say 6 years ago, the product was 324. That means if we multiply age of a daughter, which is this 6 years ago, multiplied by the age of a man 6 years ago, this gives us 324. So this will mean 3x minus 6 product 5x minus 6. This one gives us 324. So if you look at this statement here, the product, it means multiplication of their ages, It means this age and that age. It means multiplication by expansion. You get 324. So the question now comes and say, how old are they? So it means the moment to reach this point here, it means the required information is given. And where you are, it means the interpretation of which is just an equation representing the entire information you have up there. So now when you go say, how old are they now? It means you need just have to work out on this one and find their ages. So what we do here, since we know the age of the daughter represented by x, then the man is 5x. So what we do here, we need just have to find the value of what? X. So the x we get automatically, it will be the age of the daughter. The x itself will also be multiplied by 5 to give us the age of what? Of the man. So now let's go on and try to solve this equation here. Right. So the first thing that you can do here is simply by removing the brackets. That's the direct thing. Right? Because you cannot work out the value of something without removing the brackets as far as the equation has got some brackets within. So this will go just by expansion, where we have a situation like this multiplied by that. That one give us that is 3x, not 3x here, but we talk of x. Yeah, I was wondering, say, where did I get that 3? The 3 is not existing here. We all look at this x minus 3. Look here, x minus 3. So multiplying x minus 3 multiplied by 5x minus 6 is equal to 324. So what we have here, it will be x times 5x, we get 5x squared. And x times minus 6, we get minus 6x. Then minus 6 times the minus, that's positive 5x, we get negative 30x. And this one will be equal to 324. Right. So by the principles of the quadratic equations, where we said a quadratic equation is an equation which has to be equated to 0, and you can recognize it by a term which is a quadratic term. So it means that has to also be applied here. Because if you can look at this equation here, I'll be able to see that, say, this equation has got a quadratic term which is 5x squared. So though we have got like terms, but still more, we can choose first of all to equate the following equation to 0. But sometimes you can begin by simplifying this one, there's no problem. So allow me to transfer this one to this side. So here to be like 5x squared minus 6x minus 30x. This comes here to be negative 324, which is equal to 0 in that manner, in order not to breach breach the rules of the equation as such. Now, in that, what are we going to do then? We need now to simplify. More importantly, just like from this stage, everything is just obvious. It's just a matter of simplifying, until a certain stage, like as what we have been doing, you find yourself factorizing, it goes like that. So let's get through. Here we have got 5x squared. This and like terms, and this one give us negative 36x. Then we have got minus 324. Right. And this one will always have a variable here. Wait here first. We are supposed to multiply this one by that one. This gives us positive, that is a 36 is equal to that. And again, this one was also supposed, first of all, to give us, that's a, this was supposed to be positive 36 is equal to 324. Right, I left that one out, but now still more take it that you have got positive 36, this one will be minus 324. That one will be equal to 0. Right, see? This multiplied by this gives you this. This multiplied by that one gives you this. And this multiplied by this one gives you negative 30x. And this multiplied by this one gives you positive 36. So think that 36, we cannot leave it out. It's a constant that should be within the equation itself. So you go like 36 must always be there. By making this equation be equated to 0, to follow the rules of the quadratic equation, then the 324 should be transferred to the left-hand side. So that's why we have got this one coming here. Right. So when things are like that, what we have, we need just have to simplify still more. This and this, they are like terms that we have. So now here we get 5x squared minus 36x. This minus that gives us, that is 288 is equal to 0. So this means when I expand this and that, what I have is this expression here on the left hand side. But the entire we have is the quadratic equation as such. So now, from this stage, you can be able to understand this is just a clean quadratic equation. We don't no longer have good like terms in there. So it's just like now what we're going to do in order to find the value of x. So from what we have just discussed in the previous discussion, we all have three methods how we can handle this one out in order to find the value of x. So it's just like the process of choosing what method you can use to solve the equation is quadratic. You can use factor method, you can use computing of the square, you can use quadratic formula. So now, according to this, the simplest method can be via, in this case, of the factor method, where you need just to multiply this one by that one in factorizing, and that one gives you negative 1,440, things like that, which is what? X squared. Then we're looking for the factors of this that can give us negative 36, and the factors of which, according to our discussion that time, the way of finding the factors, you'd find that this one has got factors which, when you add, should give you negative 36, and the factors of which are negative 60x, and that is 24x. Right. Now from there, where do we go? Substitution, as clean as it is. So it means wherever there's this, I'll write the two factors. So here I'll have 5x squared. Instead of writing negative 36x, I'll have minus 60x, and that one should be added with 24x. And I'll end up with this one, which is negative 288. And the 0 has to be inserted like that. You see, it's more just like we are repeating what we have said. Application of what we learned in class. But here, remember, what we're doing is we're trying to solve a problem, which is in real life situation. Now, from this angle, where do we go? Remember, here we are factorizing. We can't simplify this one in the process of like terms together. It can't work. So that's why we're trying to factorize the expression. So when we write this stage here, look at the expression part of which we have now 1, 2, 3, 4 terms. What do we do with that? We group. You can remember that. We've got 4 terms need to be grouped. So the method we use in factorization is about grouping method. So here we go, like this. This and this, one group, and this and that, one group. So identify the factor that can get here and there, and again here and there. So factor getting here and there is that is 5x. So you have 5x there, and that should be divided into 5x squared, and they'll get x, and on the other part 5 gets into 60. That is what? 12. Thing like that. So you also look for the factor which can get into 24x and negative 288, but the solution of which should be the same as in the first bracket. That's the x minus 12. So the factor to divide here and there, obviously that factor will be equal to positive 24. Right. So if you take that 24 getting into 24x, the answer is x. And also 24 getting into 288, the answer is negative 12. And this one should be equated to 0 like that. Right. So from there, where do we go? Look, this expression and this expression. The two expressions, 5x open bracket x minus 12, and this other one, 24x minus 12. There's a common factor here, which is x minus 12. This one is the common factor because there's this, here there's this. So let this common factor divide into here and that. So you have got this one getting into this. You open the bracket, so this cancels with that. You have got your 5x, and this one cancels with that. You have got positive 24, and this is equal to 0. Right. So the usual system of solving is applied here. Now, where do we go? From this, I at least talked much by the first method of factorization, if you remember, the factor method. That is, if we have got two brackets multiplying and they are equated to 0, is as good as each one of them be equated to 0. So it means you have to separate these expressions in the brackets, and each one of them has to be equated to 0 in order to find the value of x. So now it will go like x minus 12 is equal to 0, or 5x plus 24 is equal to 0. Look at that. Right. So these are the two linear equations which now are very easy to solve. Right. So do the solving by arranging like terms together. Minus 12 under 0 like term. So this comes here, it will give you x is equal to 12. Here we have got all 5x is equal to this, and this give you negative 24. So here it ends x is 12. But here, to find the value of x here, you need to divide both sides by 5, which is the coefficient of x, like that. So this one goes like that, but here I've got x is equal to negative 24 over 5. Right. So we earlier said x is representing the age of somebody, who is in this case age of a daughter. But now we have found the two values of x, the negative 24 over 5, and here I've got positive 12. So if you can look at, you can consider the issues about ages realistically. There's no age of somebody be represented in negative. You always talk of positive. So here now, since I've got two values, it's not on to use both of them. But the one that does not give us that does not reflect the reality, that one has to be ignored. So here we have got two values of x, this one and the negative one. So we are there going now to ignore that is the negative 24 over 5. And then we're going to conclude that the value of x is equal to 12, because the age will always be in positive. Never shall have somebody in a negative ages. That is not true. Right. So by that, it means now we are the final stage. X has been found to be 12. So now, if we look from the starting point, if you remember, you clearly see that the daughter was represented by x as the age. So now the x here is found to be 12. So it means the age of the daughter is equal to what? 12 years. And now we talk of the man, in this case, had a representation of the 5x as the expression representing the age. Since now I found that x is equal to 12, it means wherever there's x, now I'm going to substitute for x and write here 5 multiplied by 12, which gives me what? 60. That is the story. So then, at the very end, to conclude that statement, which is more like a question, find the age of a man and a daughter, you'll be able to conclude that they say, daughter is, talk of the present, that is 12 years, and a man, a man is 60 years. Right. So that ends the discussion. Right. So you can even test this one out. Try to multiply their ages 6 years ago, which were represented by one was x minus 6, another one, so 5x minus 6. You'll be able, when you multiply, you are really going to get the same number, which was 324. Right. So students, try to get to know that there's a lot of problems in reality that can be solved. But one of the way how we can work out these ones is by use of the knowledge of the quadratic expressions and the equation. Right. So this marks the end of our discussion in the first topic of our book 3, that's quadratic expressions and equations. Thank you very much for being together.